Today we're going to talk about how to verify trigonometric identities. So our first identity here we have cosine theta times cotangent theta equals 1 over sine theta minus sine theta. Now when you verify identities, you always have to have one side of the equation look like the other. It's always easiest to start with the side that's most complicated. So this side may look more complicated because of the fraction. However, trying to turn that fraction back into something else and dealing with this minus sign here, you'd have to get like denominators and a whole bunch of other stuff. So that's just going to be really hard to try to work backwards with that. But here, it'd be easy to break this up and end up with a minus sign in the middle. So we're going to start with the left side here. Now another guideline to have when you verify identities is that you need to try to make everything look like sine and cosine. So with this cosine here, I'm going to leave that alone, but I'm going to change the cotangent. Now I know that from my identity sheet, you'll see that the cotangent here is equal to cosine over sine. So I'm going to rewrite that cotangent as cosine over sine and leave the cosine alone. After I do that, this cosine theta is being multiplied by the cosine over sine. So when I multiply fractions, cosine times cosine is cosine squared with the sine theta on the bottom. Just pretend that there's a 1 underneath this cosine here. So then when you multiply, it goes straight across, so cosine times cosine is cosine squared with the sine on the bottom. I know that cosine squared is equal to 1 minus sine squared over sine theta. And the reason I know that is because in my Pythagorean identities, it says sine squared plus cosine squared equals 1. So if I have just a cosine squared, if I want to get that by itself, I would subtract this sine squared over here, so that this would be 1 minus sine squared. So cosine squared is equal to 1 minus sine squared, which is what we have here. Now if that whole thing is over sine, now what I can do is separate it out. So I write it as 1 over the sine of theta minus sine squared over the sine of theta. So it still has the same denominator. And the way I can check is if I go back, since I have fractions with common denominators, I can combine the numerators. That's 1 minus sine squared over sine theta, which is what this previous one was. So all I did was break up my fraction. And from there, 1 minus sine theta stays the same. Sine squared divided by a sine leaves you with 1 sine, which is exactly what we were looking for. Now imagine if you had started on the right side here. If you started with this, you'd have to go backwards using these steps. And who would have thought to multiply this over here by another sine and get this sine squared over sine thing? It'd just be a huge mess. So it's easier to start on this side here and break it down. Alright, let's do another one. Do this one here, where the sine of theta times the cotangent of theta is the cosine of theta. Now the left side is definitely more complicated here because we have multiple trig functions as opposed to the one cosine on the right. So I'm going to change the cotangent to cosine over sine again. And again, just like the previous one, I'm going to multiply my fraction. So I would get sine times cosine divided by sine. Sine times cosine divided by sine. The sines would make a 1. So I have sine divided by sine essentially, so I'm just left with a cosine on top. So then I get cosine equals cosine. Let's do another one. Over here we have cosine times the tangent of theta equals the sine of theta. Again, the left side's more complicated, so I'm going to change the tangent to sine over cosine. So I'm left with cosine times sine over cosine. And again, if I multiply that, that would give me cosine times sine divided by cosine. Cosine divided by cosine is 1, so I'm just left with sine theta equals sine theta. We do another one. Number 4 here, sine theta secant theta equals tangent theta. I'm going to change the secant to 1 over cosine, because I know that's what it equals according to my identities. My reciprocal identity here. The secant is 1 over cosine. So sine times 1 over cosine gives you sine over cosine. Sine over cosine is tangent. So tangent equals tangent. Let's verify some identities using the cofunction and the even-odd ones that we learned earlier today. So here we have the cosecant of theta minus pi over 2 equals the negative secant of theta. Now, if you look at your formula sheet, anything with a pi over 2 minus theta is going to be a cofunction formula. Pi over 2 is 90 degrees, so we're taking sine of pi over 2 minus theta is cosine, cosecant of pi over 2 minus theta is secant. So we're going to use these cofunction formulas. We're also going to end up using the even and odd formulas over here as well. The even and odd formulas just have to do with the function being even or odd. So with this sine function here, if I take a negative angle measure, so let's say sine of negative 30, that's going to be the same as taking the negative of the sine of just 30 degrees. And then the cosine of a negative angle is just going to be a positive cosine of that same angle. So that's what these even and odd formulas are for. So we're going to use those as well as the cofunction ones to verify some of these identities. So this first one here, we have cosecant of theta minus pi over 2 equals negative secant of theta. And when I see that pi over 2, my first thought is that it's going to be a cofunction identity because of that pi over 2. So if I go to my cofunction formulas here, I know that the cosecant of pi over 2 minus theta is secant theta. The problem is we have the cosecant of theta minus pi over 2, so it's flipped around. So in order to flip it back, I'm going to take the negative of it. So I have the cosecant of a negative of this function here. So if I take the negative of that, theta divided by negative 1 is negative theta, and negative pi over 2 divided by a negative is a positive pi over 2. Zoom in a little bit here. Now that I have that negative out here, I've got this negative theta plus pi over 2. Now I can rewrite that. So I leave this negative on the outside and I just rewrite what's on the inside. I just rearrange it. So I have pi over 2 minus theta. So it looks more like the cofunction formula I'm used to. Now, if you think of this pi over 2 minus theta as another angle, because pi over 2 is just 90 degrees. So let's say I take 90 minus theta, let's say theta is 30, that'd be 90 minus 30 is 60. It's just another degree, another angle. So this pi over 2 minus theta is just an angle, so we can just rewrite it as theta if we wanted to. If I did that, I would have cosecant of a negative theta. If this whole thing, remember, is just another angle, so it's a theta, so cosecant of negative theta. Well, now if I go to my even and odd function formulas, the even and odd tells me that if I take the cosecant of a negative angle, that's the same as the negative cosecant of that same angle. So again, the cosecant of a negative angle is the same thing as the negative cosecant of the same angle. So since pi over 2 minus theta is just another angle, I'm taking the cosecant of a negative angle. And again, that's the same as the negative cosecant of that same angle. Well, then going back to our cofunction formulas, I have cosecant, pi over 2 minus theta, that's the same as the secant. So I change this inside part to secant, leave the negative on the outside, so I get negative secant theta equals negative secant theta. Let's do another one. Number 2 here, we have secant theta of pi minus over 2 equals the cosecant of theta. So to prove that, again, my cofunction formulas are always pi over 2 minus theta. So if I have theta minus pi over 2, then it's backwards, so I need to change it back. And how I do that again is to take out a negative. If I take out this negative, then theta divided by a negative is a negative theta, and negative pi over 2 divided by a negative is a positive pi over 2. So I just took out a negative and have it like this. Now that it's written like this, I can rearrange it so that it looks like the pi over 2. So I have secant of pi over 2 minus theta. Now that should be a negative out front there, because I still have this negative right here. Now, if I have a negative of this pi over 2 minus theta, this is just another angle, so I basically have secant of negative theta. We go to our even and odd function. A secant of a negative theta is the same thing as a positive secant of theta. So if this is secant of a negative theta, that's equivalent to a positive secant of that. So it would be secant of pi over 2 minus theta. And I know that the secant, get this over here, the secant of pi over 2 minus theta is the cosecant. So that's how I get cosecant of theta equals the cosecant of theta. And that's just a few examples on how you can verify formulas. Again, it's not too tricky. You just have to know how to use all the different formulas. And so if you just keep studying them, that will help you a lot.